Hello and welcome to a quick lesson about systems of equations with the substitution method. Now, first of all, a system of equations means you have a few equations, let's say 2, 3, or 4 of them, it doesn't really matter. You basically have some equations, and each one of those equations is the equation of a line that goes on the coordinate plane. And your job is to find out where on the coordinate plane those lines intersect. That's what the answer represents in a system of equations. The only trick is you're not allowed to draw to solve this. Instead, we're going to use something called the substitution method. Now, the substitution method is exactly what it sounds like. You're given two equations. We're sticking with two equations only, easy systems. You're given two equations, and one of them is a dead giveaway. This one here on the left, pretty easy. They're telling you, hey, y equals this. They're giving you the value of one of the variables. So what you're going to do is you're going to take that information and plug it in to the other equation. You're going to substitute it in for y. So let me go ahead and show you how it works. You have 6x minus 3y equals 15. That's your other equation, right? Well, what you're going to do is 6x minus 3, and then instead of writing y, we're going to substitute what y equals in there. So y is 4x minus 17, right? Okay, so I just plugged it in. I substituted. Now, okay, 6x, now I need to distribute, so I'm distributing that negative 3 to both items inside the parentheses. Negative 3 times 4 is negative 12x. Good. Negative 3 times negative 17 should be, yes, 51. Plus 51 equals 15. Boom. Now, we're not quite there, but we're much closer. You'll notice, hey, I have no y's left. I only have x's. Nice. That means if I only have x's I need to worry about, I can combine them. Okay, so 6x minus 12x, those are like terms. They come together and they give me minus 6x. And I also have another pair of like terms here. I have the 51 and the 15. Let me deal with that next. So negative 6x plus 51 equals 15. Now I want to go ahead and get all my numbers by themselves on the other side of the equation. So let me get rid of the plus 51 by doing minus 51. And if I'm doing minus 51, I have to do it to both sides. So on the left-hand side, you're going to cancel out the 51 and the minus 51. I'm left with minus 6x equals, that was negative 51, 15. Mental math becomes harder without copy. Yes, I just double checked my work to make sure I was right. And your answer is 36, negative 36. Okay, so now you know that negative 6x equals negative 36. But we're not quite done yet. My x isn't alone. I want to get rid of that negative 6. It's currently multiplying the x, so the opposite of multiply is divide. So I just go ahead and divide by negative 6 on both sides. Yeah? I'm just going to raise this up over here to give us some more space. But basically, once you... that guy got left behind. Okay, once you divide, here on the left, negative 6 divided by negative 6 cancels out. You're left with x equals negative 36 divided by negative 6 is 6. Boom. You just found that x equals 6. Now, we're nearly there, but not quite yet. You found that x equals 6. Remember, the solution to a system of equations is a point on the coordinate plane. And a point doesn't just have an x value, it has a y value. So what am I going to do? Well, I'm going to go back, and I'm going to go ahead and pick either one of these formulas. Either the equation on the left or the equation on the right, it really doesn't matter. I'm going to pick the equation on the left just because, hey, I think it's easier, and I don't like making extra work for myself. I'm going to take that equation, y equals 4x minus 17, and I'm going to plug in the x value I just found into that equation. I'm going to substitute. That's why it's called the substitution method. Okay, so when I substitute, I'm left with y equals, I'm plugging, y equals 4, I'm plugging in 6 for x, minus 17, right? Okay, well then, this is y equals 24 minus 17. Okay, and then that leaves me with y equals, well, 24 minus 17, that's just going to be 7.
So, ta-da! You found your final answer. Your x, y coordinate where these two lines intersect is 6, 7.